Okay, guys, uh, today we're going to be talking about the superposition principle. Okay, now in sample problem A, we use Coulomb's law. Okay, and we were when the use of Coulomb law in this case was between two charges. Now, what would happen if we have three charges? This is what we're going to be doing in this lesson, sample problem B. So, sample problem B says, okay, consider 3-point charges at the corners of a triangle where Q1 is 6.0 times 10 to the negative 9 coulomb, Q2, charge 2, equals to negative 2.00 times 10 to the negative 9 coulomb, and charge 3 equals 5.00 times 10 to the negative 9 coulomb. Now the problem says, find the magnitude and direction of the resultant force on charge 3, on this charge. Okay? Now, here I just wrote the symbols for the charges. Charge 1 is positive, charge 2 is negative, and charge 3 is positive. So let's draw a diagram. Okay, this is charge 3. Okay, here at the bottom. So we're going to find the electric force from charge 3 to charge 2, 3 and 2, and 3, 1. Now notice, charge 3 and charge 2, they have different charges, okay? Unlike charges, remember, they attract. So that means from charge 1 to charge 2, our electric force will go in this direction. This will be electric force 3, 2. Okay? That will be electric force 3, 2. Now, charge 3 and 1. Notice that they are like charges, positive, positive. Like charges repel. So instead of this charge going in this direction to charge 1, it will repel, it will go to this direction. This will be charge force, electric force 3, 1. Okay? Now, this is a right triangle, right? That's a right triangle. Notice that the electric force from charge 3 to 2 is going to the left. So we can define that theta 3, 2 will be equal in what direction to the left? 180 degrees. Right? It's going to the left. Now, charge 3, 1, if we draw this, notice that the charge was going in this direction, right? So we need to find out this angle. And these two angles are vertical angles, right? So this angle theta 3, 1 will be equal to this one. We need this angle first, right? So by using trigonometric ratios, we can use, remember that the angle opposite, the side opposite to the right angle is the hypotenuse. We can use adjacent over hypotenuse, or we can use opposite over hypotenuse to find this theta. Okay? So if we use, I'm going to use adjacent over hypotenuse. That means cosine of theta equals adjacent over hypotenuse. And that means cosine of theta equals the adjacent side 4 meters over 5 meters. Okay, we don't want cosine of theta, we want theta, so we have to multiply both sides by the arc cosine. So we get that theta equals arc cosine of 4 over 5, and theta will be about 37 degrees. Okay, so we know that theta 3,1 will be equal to 37 degrees. Okay, now knowing this, we're going to have to find the electric force between charge 3,2 and the electric force between charge 3,1. Okay, so the given information was charge 1 equals 6.00 times 10 to the negative 9 coulomb. Charge 2 equals negative 2.00 times 10 to the negative 9 coulomb. Charge 3 equals 5.00 times 10 to the negative 9 coulomb. We know R, the distance between R12 is equal to 3 meters. R23 equals 4 meters, and R13 equals 5 meters. Okay, and now we can use Coulomb's law to find forces 3,2 and forces 3,1. Okay, so let's start. Let's find first F32. Okay, the electric force 3,2. So using Coulomb's law, F32 is equal to the constant Coulomb times charge 3 times charge 2 over radius 3,2. Okay, and don't forget that the constant Coulomb, I forgot to write that down, the Coulomb constant, is equal to 8.99 times 10 to the 9th Newton times meter per coulomb squared. Okay, that's the constant Coulomb. Okay, so now we substitute, right? So we get F32, the electric force between charge 3 and 2, equals 8.99 times 10 to the 9th Newton times meter per coulomb squared times charge 3, 5.00 times 10 to the negative 9 coulomb times charge 2, 2.00 times 10 to the negative 9 coulomb over R2 squared, over radius 3,2 or 2,3 is equals to 4.00 meters squared. Okay, so we use our calculator and we get that the electric force from charges 3 and 2 is equal to 5.62 times 10 to the negative 9 Newton. Okay, so that's our electric force between charges 3 and 2. Now we have to find the electric charge between charges 3 and 1. Sorry, the electric charge between charges 3 and 1. Okay, so this will be equal to the constant Coulomb times charge 3 times charge 1 over the radius between charges 3 and 1 squared. We substitute equals 8.99 times 10 to the 9th Newton times meter per coulomb squared times charge 3, 5.0 times 10 to the negative 9 coulomb times charge 1, 6.00 times 10 to the negative 9 coulomb over radius 3, 1, 5.00 meters squared. Okay, so we get that the electric force between charges 3 and 1 will be about 1.08 times 10 to the negative 8 newtons. Okay, so we have found the electric force between charges 3, 2 and between charges 3, 1. Now we must find the magnitude and direction on charge 3, right? So remember that for this we're going to use, remember the formula, electric forces, the table, theta, Fx equals F cosine of theta, Fy equals F sine of theta. Okay, so we're going to use F32, which was, I'm going to use F31. F31, 1.08 times 10 to the negative 8 Newton. 3.1, remember, the angle for 3.1 was 37 degrees. Now we use 1.08 times 10 to the negative 8 cosine of 37 degrees and 1.08 times 10 to the negative 8 coulombs times sine of 37 degrees. Okay, and take out our calculators. For cosine we get 8.63 times 10 to the negative 9 coulomb, and for sine we get 6.50 times 10 to the negative 9 Newton. Okay, now we use our second force, our second electric force, which was F32, 5.62 times 10 to the negative 9 Newton. Theta for 3.2 was 180 degrees. So now we complete the table. 5.62 times 10 to the negative 9 newtons cosine of 180 and 5.62 times 10 to the negative 9 sine of 180. So for cosine we get negative 5.62 times 10 to the negative 9 newtons, and for sine we get 0 newtons. Now we find the summatory of Fx. That will be 5.63 times 10 to the negative 9 minus 5.62 times 10 to the negative 9. And for that, in summatory of fx, we get, once we add this in our calculator, we get that the summatory of fx is equal to 3.01 times 10 to the negative 9 newtons. And for the summatory of fy, we get 6.50 plus 0, 6.50 times 10 to the negative 9 newtons. Okay? Now, magnitude. Remember, magnitude will be equal to the square root of the summatory of fx squared plus the summatory of fy squared. So magnitude will be equal to the square root of 3.01 times 10 to the negative 9 newtons squared plus 6.50 times 10 to the negative 9 newton squared. So the magnitude will be equal to, sorry about that, 7.16 times 10 to the negative 9 newton. That will be the magnitude. That means that will be f of 3 total equals 7.16 times 10 to the negative 9 newton. That is the magnitude on charge 3. Okay? Now how do we find direction? Direction will be theta equals the arctangent of summatory of fy over summatory of fx. Okay? Notice, x is positive, y is positive, so that means that our angle, our resultant, must be in quadrant 1. Okay? So theta will be equal to the arctangent of 6.50 times 10 to the negative 9 newton over 3.01 times 10 to the negative 9 newton. So theta, that direction, will be about 65.2 degrees. Okay? So magnitude, the total force on charge 3, 7.16 times 10 to the negative 9 newton, and theta, that direction, 65.2 degrees. So again, once you start working, you must find, don't forget that like charges repel, unlike charges attract. This is why. Positive, negative attraction. That means the force on charge 3 will go in this direction because there is an attraction to charge 2. Now, from 3 and 1, notice that both charges are positive. There is a repel. So that means that this force, instead of going to charge 1, it repels in the opposite direction. So this is why we get our sketch F32 to the left and F31 opposite to the direction of charge 1. Okay? And for each of the forces that you find, don't forget to find their corresponding direction. In this case, the charge from 3 to 2, since it's going to the left, the angle will be 180 degrees. And from 3 to 1, since this is a triangle, a right triangle, we use trigonometric ratios to find the angle, and we found that the angle was 37 degrees. Okay? So you find each of the charges, and then Don't forget to use that table. This table, we use it on chapter 4, I think, I don't remember. Okay, so we have to go back to using this table in order to find magnitude and direction of the charge of the electric force on charge 3. Okay, so that's it. Your assignment will be practice B. There are just 2 problems and the chapter review. Don't forget, if you have any question, text me or call me. Bye guys.